Hello, my name is Andreas Doms, refrigeration and air conditioning engineer. Since I'm often present at the commissioning of refrigeration systems, I would today like to show you how, with the Testo 570, I can commission refrigeration systems very securely and efficiently, and also provide documentation. Okay, the plant is ready, filled with refrigerant, and the fitter has given the go-ahead for commissioning. I attach the manifold to a secure point on the plant. In order to record the subcooling of the liquid, I clamp the sensor to the liquid pipeline in front of the expansion valve. To record the evaporator's superheating, I attach the probe to the suction pipe right behind the evaporator. I then connect both sensors to the instrument. I now switch the instrument on. A self-test runs. I can now switch on the backlighting. Before the manifold is ready to work, I have to select the refrigerant. In this case, refrigerant 134A. And then zero the pressure sensors. All valves on the manifold are closed, and I now connect the low pressure side of the system to the instrument. I now connect the high pressure side of the system to the manifold and open the valve. Okay, the system is now in a steady state, and on the left-hand side we can see our suction pressure. On the right-hand side, the high pressure and the corresponding saturation temperatures, in this case 2.1 degrees Celsius evaporation temperature and 38.4 degrees Celsius condensation temperature. This suits the ambient conditions very well right now, and by pressing this button, I can also see how the probe temperatures can be read out. On the one side, we have a temperature of 6.7 degrees Celsius at the exit from the evaporator, and the liquid temperature of 32.8 degrees Celsius at the moment. If we switch further, we obtain the values which are so important to engineers in the field, namely subcooling and superheating. On the left, we see the superheating of 8.8 Kelvin right now, measured at the valve, and on the other side, a subcooling of 5.7 Kelvin before the expansion valve. These values are good enough. You could alter the valve value a little, but basically the system is very well adjusted. There are two methods of documenting these measurement values. For one, via the interface to the EasyCool software, and the other is directly on site using a wireless printer, which reads the measurement values out of the instrument by infrared and can print them right away. As you can see, I have been able to take this system securely and quickly into service with the Testo 570. Important operating parameters such as subcooling and superheating could be constantly displayed, optimized, and printed out as required. This allows the fitter to hand over an operationally secure plant, ensuring his customers are satisfied.